We're going to start with reducing radicals, and again, we're going to start with square roots because we've done that before. If you didn't remember how to do it, I know a lot of people on the test did it in their calculator, and then they tried to work backwards to get their work, which is fine, provided that you could actually do that. Some people tried to work backwards and had some pretty interesting work that didn't make sense. But if you didn't know how to do it without your calculator, now is when you have to learn how to do that. Because when we get down to the third roots, you're going to be in a little bit of trouble if you only can do it with your calculator, because your calculator does not do third roots for you. So these are the same steps from before. Step one, we're going to find two numbers that multiply to be the inside number. That's called the radicand. One of them has to be from our list, and our list is the one that I gave you guys. So the way we're going to do that is we're going to start where our number is on the list. So this 108, we're going to start squared, because it's a square root. We'll talk about that in a second. 108 would be right here between 100 and 121. So I'm going to start with 100. I'm going to work my way down until we finally get one of the factor of 108. So in my calculator, I hit 108 divided by 100. That's going to give me a decimal, so 100 doesn't work. Then you're going to do 108 divided by 81. That's a decimal. That's not going to work. You're going to keep going until you get one that's not a decimal. Now, again, same thing I said before. I know this sometimes takes a while, and I get it's a little bit time-consuming, but please make sure you realize it's not hard. That's one of the things that I feel like is the difference between somebody that's a little bit lazy and somebody that just that math comes hard to them. If math comes hard to you, yes, we can figure that out later. But if you think this is the worst thing ever, it's just because you're being lazy. Because you're just typing numbers in your calculator. So 108 divided by 64, decimal. That doesn't work. 108 divided by 49, decimal. That doesn't work. 108 divided by 36. So we got 36 and 3. So 108 divided by 36. Oh, I winning. 108 divided by 36 is 3, which means, you guys all know this, if 108 divided by 36 is 3, that means 108 is the same thing as 36 times 3. The square roots around those, because technically we're not looking for 108. We're looking for two numbers, the square root of 108. So instead of 36 and 3, it's the square root of 36 and the square root of 3. So that was step 2. We split up the original radical into two radicals, 36 and 3. One of them has to be from our list. That 36 has to be from our list, and it's going to help if you always go down the first. That's going to make your life a little bit easier. Now, the reason we picked a number from our list because it reduces really nicely. 36, the square root is a whole number, is 6. That's why we chose it. 36 is 6. I had people on their papers that had like 15, and then the next step they had 5. This is not 5. That doesn't make sense at all. I mean, I'm not trying to make anyone feel bad. That's one of the things you get to work. How do we get the 6? Well, it's because that is the square root of 36. That's what I do. Don't do it the way I'm telling you. You can't do anything with that square root of 3, so it just stays the square root of 3. Now again, I know your calculator does this work for you, so for this problem, I really need to see that step. Later on with number 5, 6, and 7, I'm not going to be as particular about it. Because your calculator does. And I still need to see your work because I always need to see your work. The ones that if you had the right answer, I didn't give you any credit still. I needed to see that work. There are a lot of people that when they solved this problem, they said the square root of 108 was 54 times 2, and then 54 divided by 2 is 27, or something like that. You do not want to use 54 and 2 because neither of those numbers are on our list, and the reason is because the square root of 54 is a decimal. It's not 27. So again, we pick a number from our list because the square root of that reduces, it's not going to be a decimal, it goes to a whole number. That's the whole idea of this. So let's move on to 245. So square root of 245, again, if you go over root, so over here. Now again, trial and error, 245 divided by 225 is a decimal, divided by 196. I will tell you, you're more than welcome to skip over some that you know don't work, but I would be careful because that's happened to me, and the one I skipped is the one that actually worked because I'm not super smart a lot of times. 2 by 169 doesn't work. Divided by 144 doesn't work. Divided by 1 doesn't work. Divided by doesn't work. Time I go back to make sure it is 245. Didn't make a mistake there. That's also happened. 245 divided by 64 divided by 49. There, 49. So you finally got 49 times 5 is 245. So over here is my 245. Now again, I know this is not the easiest thing ever, but the good news is there's places to check your work. 49 times 5 better be 245, and then 49 is from our list. Once you got that, the whole reason we did that is because the square root is just 7. The square root. Do anything with that. Real quick, I'm going to have you go ahead and do number 3 and 4 on your own. I'm going to put up the answers here in a second. All right. So I put those 2 answers up there. I will tell you one of the 90 is a dangerous one. I guess I should say 90 is similar to one that's dangerous because most of you guys know 9 times 10 and 9 is a perfect square. That does work for this one, but remember, make sure you're careful because occasionally you get one where the radical, you can still reduce more. So like I've had one with 60, where they have a square of 20 in here, it's like 3 times 20. But that 20 can still be reduced more. So if you do it the way I told you, where you start with that list, you start with the biggest numbers, it takes a little bit of time, but the good news is you will never have to reduce it. Whatever you get, it's going to be your answer. So you don't have to worry about that as much. Any questions on those? Next couple problems, once we get into the exponent, so it's a little bit different. But the next 4 or 5 problems are done pretty much the same way. The only difference is a different column on our chart. So first off, I want to point out that technically a 2 in front of each one of these square roots. The reason they don't put that in is because we use the square root so often that they kind of figured, yeah, you know what, let's just assume that if we don't put it, it's a square root. And that's why you guys have all heard about square roots. You probably haven't talked too much about cubed roots. Square root's super common, so if you don't see a number in front, that means there's a 2 in front of there. There's a third root. Now the third root is exact opposite. You know how if you squared, that's 4, so the square root of 4 is 2. It's the same thing here with the third root. 2 to the third is 8, which means the third root of 8 is 2. The difference between using a square root, an exponent of 2, exponent of 3. You probably know that. I don't want to talk about it just in case. Make sure we're all on the same page. So 162, again, we do the exact same thing. So 162, the only difference is now we are using this third column. Third root, I'm using the third column. 162 is the number we're starting with, so 162 is here. I kind of like third roots a little bit better because until you get a really big number, it's actually still pretty short. Like you can have 1,000 and that's still only a couple down there. Keep forgetting. In your calculator, divided by 125 is a decimal. That doesn't work. 162 divided by 64, decimal. Doesn't work. 162 divided by 27. That one does work. 27 times 6. So this is the same thing as 27 times 6. But don't forget, it's the third root of 27 times the third root of 6. You do need the 3's in there. It's maybe one of the most common mistakes. Forgetting 3's as we're going. Now this part might be a little bit more difficult because you're not as familiar with the power of 3. But what is the third root of 27? Again, if you don't know, you can either use a calculator or use your chart. The third root of 27 go all the way to your normal x numbers. The square root of the third root of 27 is 3. So again, that's the reason we picked the number from our chart. And that reduces down to 3. The third root of 6 doesn't change at all. We can't do anything with that. So that is your answer. Now, the other thing I will say is the calculator will not do this work for you. It will give you a decimal instead of writing out in that notation. However, you can still use your calculator to do this. It might be in one of the menus somewhere, and I'd have to look on your Casios because I'm not super familiar. But if you put in the third root of 162 and hit enter, it gives you a decimal. That better be the same exact decimals if you put your answer in. 3 times the third root of 6. Because that's the whole idea. We're not changing it into numbers. We're just putting it in a different notation. That's the whole idea. We're just simplifying it. Again, I used this analogy before. The thing is, if I have 6 over 8, that's the same thing. That's the exact same number as 3 over 4. The next one's 5. That is right here. Divided by 12. Divided by 340. So there we go, 125. So 125 did work for that one. That is 125 times 5. Again, they're both third roots. Just like we said, the third root of 125 is 5. If you look, third of 125 goes over here is 5. The third root of 5. So a little bit more difficult, so go ahead on your own. Again, in a little bit, I'll put up the answer quick. All right, my answer's up there. Any questions on the? Okay, we did the square roots, all the same. So moving on to the next one is the fourth roots. Spoiler alert, it's going to be the same exact thing. The only difference is now we're using the fourth column since it's the fourth root. Is this one. So 725 would be right about here. Same as before. 729 divided by 625. That's a decimal. That doesn't work. 729 divided by 56 is a decimal. That doesn't work. 729 divided by 81. That does work. Was 729 the number? Did I write down wrong? Let me check the dang thing real quick. Oh, no, we're good. We're good. We're good. Okay, so interesting thing. I'll tell you why I was confused, because it does confuse you guys as well. And I'm going to act like I did it on purpose so my self-esteem isn't hurt. So 81 does work. So 81's good. So over here, I have 81, the fourth root of 81, times the fourth root of 9. I was panicking because the 9 is a perfect square. The square root of 9 is 3. So I was like, wait, I did something wrong because, well, yeah, it is a perfect square, but that's not what we're doing. We're doing the fourth root. So that is genuinely one of the things a lot of students get stuck on. see that 9, then you think it should be 3. The square root of 9 is 3. You're right, but this is a 4th root. So the 4th root of 9, if you look at that one, there is no in this 4th root column. So the 4th root of 81 is 3. I go all the way to the left. And the 4th root of 9, you can't do anything else with. With 3 times the 4th root of 9. Definitely don't be intimidated by bigger numbers with this, because obviously that's the whole nature of exponents. But if you look at your sheet, even with the 4th root, and we won't go much further than the 4th root, but they get pretty big pretty quick. You're only a couple down before you're in the hundreds and the thousands. And all right, go ahead and do number 9 on your own. I'll give you guys a bit. So I'm getting 5 times the 4th root of 3. Again, make sure you don't forget the index number up here. That is very important. Any questions on those? All right. So the next one we have is when we have the square root or the 3rd root of the 4th root, but we have variables. Now, when we have this, we have 3 different categories, and the category, the second one, is the one that's the most difficult. You can probably tell because there's a whole list of steps on how to do that. So the first option is if you take your exponent divided by your index number, that turns out to be a nice whole number. That cancels out the radical. You go ahead and put that whole number when you divide it, and you're done. So for instance, again, this is a square root, so there's a 2 there. 4 divided by 2 is 2, it's a whole number, so this actually reduces down to x squared. X to the 4th, but we're taking the square root of that, so that is x squared. By 2 is 10. Since those end up as whole numbers, we're good. That cancels the radical, and we can put that in division. Now, even if they have a square, it's still fine. 21 divided by 3 is 7. This ends up being x to the 7th. You get a whole number. Number 13, 44 divided by 4 is 11, so that's got to be x to the 11th. So that's the first one, where it divides nice and evenly. You get rid of your radical, and it's awesome. That's the best one. That's the easiest one. One of the easiest ones, I should say, I guess. In the next category, the whole objective is we want to work it down to one of them like that. That's all it is. So in the second category, we're going to try to manipulate this, and so we end up where we do have one you can reduce down really nicely like this. That's the whole idea. So this is the one that gets students a little bit confused, and I think if you do enough of these, it's not terrible. So the next category is if they do not divide out evenly. So if you don't divide out evenly, you get a decimal. So like 7 divided by 2 is 3. That does not work. So here's the whole idea. Again, we want to multiply to be x to the 7, but the whole idea is we want one of them to be where it's an even exponent, so we can divide by 2. So find the multiple of the index number that is as close to the exponent as possible without going over. So find the multiple of 2, because no multiples are like 2, 2 times root is 2, 3 is 6, 8, 10, 12, those are all multiples of 2. Your index number, that's going to be as close to your x without going over. That's the key, not getting bigger. So for instance, the biggest one I can get is 6. You can't do 8, that's too big. most of my exponents over here. How many exponents do we have left? One. So that goes over here. X to the first, and it's still the square root. You don't actually have to put. Now remember earlier with these numbers that we did up here, the whole idea is that we took out one of them that we did know that we reduced down really nicely without any fractioners. So that's cool, so that's what we did. It's still the same rule with this one. The reason we take x to the 6 is because 6 divided by 2 is now 3, so that cancels out. And then the only thing we have left is the square of x, which again, that goes with our problem. It's just the square of x. So this one is x to the third times the square root of x. You know, it's kind of confusing. Once you do a couple of these, it shouldn't be too bad. So for instance, what is a number that is as close to 29 as I can get without going over? That is 3. That's a multiple of 3. 27. So 27 would be a good one. So we're going to break this up. That's x to the 27th times x squared. One quick way to check your work. You need all your exponents accounted for. So if I took 27 over here, I have to have 2 more to get that 29. Don't forget, it's obviously the third root of both of those. 27 divided by 3 is 9, so I have x to the 9th. The rest of it doesn't reduce at all. So we end up with x to the 9th times the third root of x squared. Now again, some of you guys probably have the pattern already, so you know it's not too bad. You've probably done 16 or 17. So we have 24 and 4, or sorry, 27 and 4. So what's the number as close to 27 as I can get without going over? That's a big deal. Let's see, we do 16. I think 16 has to be it. Yes. If we're being honest, I don't even remember what number I did say. So again, this is what a lot of kids get tripped up with. They can't figure out what the second exponent is. Again, if we have 27, we're taking 24 out. I need 3 more. We need those to still be 27. These are, don't forget this, these are fourth roots. So 24 divided by 4 is 6. Three and 4, we can't do anything else with that, so that ends up just being the fourth root of x to the third. That's super sloppy. It's not my day. Last but not least for this one, 16 and 5, what's the multiple of 5? If it's close to 16 as I can get. If you watch the video, that's one of the reasons I'm doing it. I put, my answer was 10. That's not the right answer. Should be 15. So x to the 15th. Fifteen divided by 5 is 3. That's the whole idea. Again, anytime you do that division step, you can cancel out the radicals. Oh, geez. Again, those two exponents need to add up to be 16. So we have 15 here. We have 1 over here. The fifth root of x to the first isn't going to do anything. It's just the fifth root of x. What's the, oh, because I. We're not in a hurry. We can take our time with this. So if you look at 18 down here, what's a number that's a multiple of 5 as close to 3 as I can get without going over? There is a negative. The first multiple of 5 is 5. So you can't do 5, it's already over, so that's already simplified. That's the whole idea. Over here, this is a 1. That 1 is smaller than a 5, so that's over. This one was also supposed to be a 3 maybe. Oh, because I erased it. This 2 is smaller than the 3. This 1 is smaller than the 2. They don't really have to put the 2. Make sure your writing is clear. I know a good example because I don't have good handwriting, but also this thing makes it worse. But a lot of times exponents with square roots kind of start combining to look like this is a cube root, so just be careful of that for your own purposes mainly. Any questions on those? Nope. Okay, the next thing I'm going to tell you is confusing, and if you are interested in mathy stuff, then you can pay attention. If you are not interested, this is not going to be on a test. This is not going to be on a quiz. I feel like, I know this sounds ridiculous, but mathematically speaking, I feel like I have an obligation to tell you, but I think it's ridiculous and I don't want to go too much into it. So the whole punchline, I'm going to try to get to where I can explain the reasoning of why. The whole thing is that if you can't, if you square a number, if you have an even exponent, it's always got to be a positive number. But you could take, so you can't take the 4th root of a negative, you can't take the 6th root of a negative, but you could do it with a 3 or an odd number. So the whole idea is that at a certain point, you need an absolute value. That's not a good way to describe it, but it doesn't matter anyway, so that's basically the background. So there's the rule, and honestly, one of the reasons I'm telling you is I thought about putting 1 or 2 of these on the test, and if you do this, I'll give you an extra credit point. If you don't, it's not a big deal. But it's called, what I call the even odd rule, where they're talking about your index, the inside of your exponent, and the answer exponent. If the index number and the inside exponent are both even, and then your answer has an odd exponent, then you need to put the absolute value. So for instance, example, this index number is 2. This exponent inside is 10. Exponent outside was 5. So even, odd, we needed absolute values. This is 4, 28, 7, even, odd, but absolute values. These are ones that don't have absolute values. 2, 12, and 6, even. 3, 36, and 2, odd, even. Square 13, so even, odd, even. That one's still automatic limit, so that doesn't matter. So, again, I'm going to put an extra credit question like that, or not an extra credit, I just might put one on there and give you extra credit if you remember that. But that's one of those things that I remember in Goshen, they always wanted us to teach that, and every time I was like, this is the most ridiculous thing. Talk about stuff you're never going to use in life. That's a good one. He actually taught me how to do it before class. I didn't have this in the notes before. All right, I have those there. Again, if you have questions, make sure you're asking. I will, by all means, come explain it to you as much as I can. So, again, this first one, I chose 40. Has a multiple of 2, as close to 41 as I can get without going over. If I have 40 exponents here, I need 1 exponent over here. I need all my exponents taken care of. So now, 40 divided by 2 is 20. That's what I wanted. Whenever you do that division, you cancel out the radical. I put a 2 here, still you don't really need it. But then we're left with the square root of x to the first, because we couldn't do anything with that second part. Number 20, 22 divided by 2 is 11. You don't need to do all that work. If you try to get a number as close to 22, that's divisible by 2 without going over, it's 22. The fourth root of x to the 22nd. So again, the closest number I can get that's a multiple of 4 is 20. But that means we have 2 left over. We'll deal with that later. 20 divided by 4 is 5. That's how I get x to the 5th. This fourth root of x squared, we can't do anything with. That just stays the same. It comes down. You won't have one like this on a test or a quiz. I just wanted to put it up here just to make sure you can see it. That one is simplified. And again, if you try to do that one, what's a multiple of 4 at close to 3 without going over? There is none. 4 is the smallest multiple of 4, and it's already too big. Last but not least, 23. Again, it's x, the third root of x to the 38. So the closest I can get is 36, which means we have 2 of them left. 36 divided by 3 is 12, I think. I'll put that in the calculator, so I can guess myself. So that's x to the 12, and then the third root of x squared. Again, we can't do anything else with that. One of the common mistakes is making sure you realize 40 and 1 make 41. 20 plus 2 is 22. 36 plus 2 is 38. You want to make sure all your exponents are accounted for. How was that? How do you guys feel about that so far? Hopefully not too bad. So the next thing we're doing is we're combining both of these. Oh, what is it?
Number 20, like that absolute value thing, is that like a rule, like we have to do that?
No. Yeah, but that's a good example. So if you look, this one is equal to x to the 11th. So we have an even index number, an even exponent, and an odd exponent. So technically that would have absolute values. But yeah, if you put that, like, again, I might put one like that on the test, where if you do it, I'll give you an extra credit point. If you don't do it, then... All right. So, we're just combining both of these in one problem. Don't make this harder than it is. I'm not saying it's easy at all, but it's not any more difficult than what we just did. Because the first thing I do, remember how we did this earlier when if we had, might as well scroll up and show you. When we had square root of 108, I can separate that to 36 times 3. You can still separate that into a multiplication. Well, that's what we're doing down here. Same thing, the very first step, 80 times x to the 15th. I'm breaking that up into, trying to break it up, 80 and the square root of x to the 15th. Both of those individually. So it's the same thing we did before. The square root of 80, go ahead. Again, don't be scared to use your exponent sheet. That's the whole reason I give that to you. About here, which looks like, I want to say 16 maybe. Cool. Times 5, so the square root of 16 is 4. 5. That's just it. We do the same way we just did. As close to 15 as I can get without going over. That's going to be 14. So that leaves me with one more exponent. The square root of x to the 14th is x to the 7th. The radical. That's another common. A lot of people put x to the 7th, but they still have that square root in there. That cancels that. That's the whole idea. And this other part, we can't cancel anything with that. So last but not least, to put this as your answer. So right now we have two separate answers. All you have to do is everything that's not inside of a radical goes in front on the left. everything that's inside of a radical goes together inside of one radical on the right. So for instance, the answer to this one is 4x to the 7th, the two things that are not in a radical. And then you put your radical sign, the things inside, we have a 5 and an x. That is your answer. Again, I'm not standing up here and saying that is easy, because it's not. It's difficult. I get that, for sure. But it's not any more difficult than what we did earlier today with this stuff. It's just combining both of them into one problem. Now, I'm not going to torch you with too many of these, but number 25, if you think about it, I can put as many variables in here as I wanted. I could have 648, x to the 23rd, y to the 30th, z to the 15th, a to the 44th, b to the 20th, c to the 2nd. I can put as many of those variables because, again, you just split it up, you're doing them separately. I'm going to have to erase this so I have room. Sure. So I split this one up. We have the third root of 648, the third root of x to the 23, and the third root of y to the 30th. Just split it up into 3.
So I noticed it back on 21, you don't have to scroll back, but is the absolute value, does it only apply when it's only an x to the variables?
Yeah. Yeah. If you put absolute values in your, unless you put it on every single one of them, assuming then you'll get the one right with the extra credit because there's one. Then, anyways, it's a bold strategy. I'm going to give you a point actually because it's a bold strategy. So again, now we just break down each one of these. So 640 root, so the third power, 648 is in here somewhere. So let's see, 648. That one doesn't work. 512 doesn't, 343, 216. 216 and 3. 216 is 6. So we have 6, third root of 3. Then x to the 23rd to the 3rd, the closest I can get is 21. And again, that means we have 2 extra to get 23. So 21 divided by 3 is 7. And then we can't do anything about the third root of x squared. At least 30 divided by 3 works out really nicely for us. That is just y to the 10th. We don't have any radicals with that because it all reduced down. So we have this one. These 3, everything that's not inside of a radical goes together. We have the 6, x to the 7th, and y to the 10th. Then we put my radical, it's the third root, and then we put everything else that's inside. So I have a 3 and an x squared. Any questions on those? Bad until I'm in the middle of it. Yeah, this is not. I'm going to go ahead and do these 3. If you want to start on your worksheet and work on your exit ticket, that's up to you. That's on you. But I'm going to wait a second, and I'm going to put the answer to these 3 up. All right, those answers are up there. Sorry if you can't see them super well. And again, my main concern about these problems, they are difficult. There's a lot going on, but it's the very first lesson we have in this chapter. And so I'm worried that some of you guys that understand how to do it and clicked, make sure you're still doing worksheets, exit tickets, and your practice tests whenever we have it. Because it's going to be a while until we take the test. Shorter than usual, kind of unfortunately, but want to make sure we do well.